ठीक है, माइक पे ठीक है। हेलो। हेलो। मिस कीर्ति के।
Yes, sir.
Shall I? What is your paper ID? Shall I need? Shall I know?
144.
144, na? Okay.
Yes, sir.
Yeah, all right, sir.
Keep name, write the name.
Hello, Miss Janvi Anil Patel.
Yes, sir.
Shall I know your paper ID?
Yes, it is 30.
It is 30.
30, yeah, 30.
Okay. Oh. This is card. Hello, Miss Karthik. Mr. Karthik. Hello, Karthik. Hello, am I audible to you?
Is it?
Sir, shall I know your paper ID?
Paper ID is 138. Can you share my screen for the PPT?
Is it 138? Was clear नहीं हुआ.
But it is asking.
Okay, sir, Karthik sir, will you share me your paper ID, please? I'm not. I'm literally can't audible you. Hello.
So, kindly ask of my friend to join in the meeting. I will waiting
No, sir. Karthik, Mr. Karthik, I
Yes,
want
sir.
your paper ID. What is your paper ID?
Paper ID is 138.
Okay. Hello, Mr. Karthik.
Yes, sir.
Hello, Mr. Karthik. I tell you that you will be the first guy who present the paper here. Okay.
Okay, sir.
Okay. Be ready here, and for the presentation, be ready. Okay.
Okay.
You will be just 10 minutes for paper presentation and
Okay.
5 minutes for Q&A. So total you have 15 minutes. Okay. 10 minutes for present your paper and 5 minutes for Q&A. Okay. Am I clear?
Okay. Okay, sir.
Okay.
Excuse me, sir. Excuse me, sir.
Hello, sir. Am I audible?
अरे खेल के
Can we start our presentation, sir?
no, sir. I will tell you when will you start. Okay. Sir, shall I know your paper ID? Which is your paper ID?
Okay, yeah.
Okay, sir. 138, sir. Paper ID.
138.
Yes, sir.
Yes, 138 है ना actually.
Sir, we both doing the same department.
Okay. Okay, you both in the same paper ID, yes?
Ah, yes, sir. We are doing the same project.
Okay,
we are
okay.
going to-
Okay.
Go sequentially.
Okay. One more, sir. 86. Sir.
Okay, ma?
Sir, I sir, 86 का clarification नहीं है.
Who is the paper ID?
I don't know.
That's a inform. They will respond.
Because सबको unmute कर दूं क्या?
No. You just inform. They will unmute themselves and mute on.
So.
They can unmute.
Okay. And a direct question, sir. Who is the paper ID 86? Shall I know? Hello, am I audible?
Yes, sir, you are audible.
Who is paper ID 86? But I think we need to unmute all. Yes, sir. Yes, sir.
आप ये देखो आप better to inform to the field, sir.
Yes, sir. Hello, am I audible?
Yes, sir.
Has anyone anyone told me who is paper ID 86? Hello.
Good morning.
Glad morning, sir.
Hello everyone, and welcome to the 2023 ICBDS session for IEEE, and very heartily welcome to you to all people who is here. And we have here our internal sir, Dr. Sailesh Kapler sir. We mostly welcome you, and also our sir, Dr. Sunil Mane sir. Sir, am I audible, sir? Dr. Sunil sir?
Yeah, you are audible. Please go
Yes, sir.
ahead.
Yes, sir. Yes, sir. So I'm not taking all your time because we have very less time. So I'm asked to all people, and I'm saying to all people that you have only 10 minutes for explain your and present your paper, and 5 minutes for Q&A. So you all have 15 minutes only. Total 15 minutes you will have. Am I clear to all that you will have 15 minutes, 10 minutes for paper presentation, and 5 minutes for Q&A? Am I clear to all of?
Yes, sir.
Am I clear now?
Yes.
Yes, sir.
Okay. So, please welcome for the paper ID 138 to start their presentation. Please start your presentation.
Can I share my screen and share the presentation, sir?
Yes, yes, please start.
Okay, sir. So we are glad to be here at the presentation of IEEE conference in ICBDS 2023. We are going to start, and our title of the presentation is Accurate Face Mask Detection Using CNN. This is Durkesh and my friend Karthikeyan. So our objective of the project is to detect the presence of face mask in human faces. This will reduce the spread of diseases among peoples.
Please
Yeah.
speak, sir, very high, sir. Increase your volume, please, sir.
Yes, sir. So significance of our project is like we already know that pandemic situation COVID-19, everyone was scared of the disease spread. So the World Health Organization suggests everyone to wear mask. For that, we have developed a system which will detect the presence of face mask automatically. Our methodology is very simple. We have collected the data first and we pre-processed the data and then trained our model. Then we have give input and get the best results. Like I said, during the pandemic situation, we all faced a very difficult situation. To overcome this, we have learned to wear mask. But in public sectors, we don't guide everyone to wear mask by manpower. So we have developed this CNN architecture to detect the presence of face mask. So we are going to show our architecture through this presentation. The methodology is continued by my friend Karthikeyan.
So this is Karthikeyan, and our methodology of our project, which includes data collection, data pre-processing, and the model training, testing, and the real-time evaluation. The process starts from the importing some several data sets, which includes Kaggle data sets. We are importing from the Kaggle libraries, which is in the form of a zip file, and we are extracting to the files and the data folders which contains with and without maskers. And also we are importing several differences, which includes OS, Matplotlib, and several libraries, NumPy, and CV2, Influ, Pillow, etc. And then we are segregating these folders into encoding part, and we are going to create the labels to those data sets for the images which contains the mask are labeled as 1 and without mask as 0. And we are combining those lists into a common list called data. And then image processing section, we are going to resize the image so that we can have same size of the pictures. So resizing the images, and then we are converting those images into a NumPy arrays, and we are going to convert those black and white images into RGB colors. So these are the techniques we are used in image processing, and then we are converting this data list to NumPy arrays, and the training and testing part comes over, and scale and then scaling the data. We are going to scale this data as NumPy arrays, or which is from the 0 to 255, and we are going to scale this from 0 to 1, so that image prediction will be easier for us to predict whether it is a mask or wearing mask. And then we are going to build a CNN model, which includes several number of layers, consists of a 2D conventional layer, next pooling layer, flattened layer, dense layer, and dropper layers. And after building our model, we are going to train our model by providing the valid data sets without masters, so that the model can predict whether the patterns, and several neurons can give a light on the to predict whether the mask wearing a mask or not. So that model evaluation consists of several techniques such as F1 score, recall, and precision to predict whether the system is predicting our model accuracy. And the accuracy rate of our model provides the 98% of the prediction. So this LGA project.
Karthik, your slides are not moving. It's on.
So this is a methodology. This is methodology of our project.
It is paused here.
Yes.
Can we directly go to the architecture of your this thing?
No.
Proposed solution. What is the architecture?
Sorry, sir.
Can you get my question?
Sorry, sir. I cannot understand what you are saying.
Yeah. I said, what is the architecture of your?
It's
this
95
proposed
to
solution?
98%.
Can you just show us the architecture? Is it there in the slide?
No, sir.
Okay. Okay, fine. So, can you just go back?
Yes, sir.
Again, go back. So what is the data set? Is there any data set which is standard used by you, or you created the data set?
So we are imported for the data set from the Kaggle site.
Kaggle library.
Yes.
Yeah, repository. Okay.
So,
what is the size?
The memory space, your memory space, or the count of images. So what's your question? Can't understand.
Yeah, size of the data set. How many images were there?
It's about 7,000.
7,500, sir. With
500. Okay.
yes, sir. It is equally distributed with mask consists of 3,700 something, and without mask consists of 3,800.
Okay. Okay. So, did you tested your solution against the real-time images?
Yes. Yes, sir. We have really captured our my friends' images, and they are imported into this project, and it is accurately finded the images with not wearing the mask and with fear.
Okay. Can you go to the result? Okay. There might be some existing methods which are designed for detecting not only mask but some other parameters on the face. Okay. So how your solution is unique, or what it makes it unique other than all other existing solutions?
Our model is unique from those already existing projects, which provides high accuracy rate, and we have implemented sigmoid function, something which is used to predict whether it is used 0
Which
or
function? Which function?
sigmoid function,
Sigmoid
which is probably used in logistic regression in machine learning. And for the execution system, they used some region of interest to predict the pixel values in those images, a region of interest, and some other open CV sources to predict whether the images are wearing those masters or visual masters. And we are going to predict whether the images using the pixel values in array arrays neurons.
Yeah, that is all okay, but I could not see the study of existing methods. Okay, throughout your presentation, you just explained your method. That's absolutely fine, but the comparison is also required, right? So, what are the various existing methods? What are their accuracies, and what is yours? So that comparison is missing in the presentation, I think.
We have included also references links.
Sir, can all people open their camera, please? Start the camera. Start the please. Camera. We won't able to see you here. All people, yes. Everyone, please.
Yeah, at least we can make.
Continue.
Yeah. So I think at least we can make a rule that while presentation, we ask them to keep the camera on.
Okay, sir.
Yeah, for the presentations. All others also note it down. Okay. Yeah. So that is all. I mean, is there any other question from any participants for this method? Okay, Karthik, just explain what is the accuracy is too high. I mean, 98.5 is a very good accuracy. Why you are getting a very good accuracy? What is the reason?
The main reason behind this is we are converting it into a new NumPy array, and we are scaling those NumPy arrays into some numerical values from 0 to 1, so that for identifying whether the images is wearing a mask or without mask is easy, because probability rate from predict the values from 0 to 1 is very easy. So the probability of wearing a mask is whether it is high or it produces values predict whether it is wearing a mask or not.
Okay, fine. That is all from my side. We can go with the next presentation.
Thank you, sir. Karthik, good morning.
Yeah.
Dr. Shailesh here.
Glad morning, sir.
Actually, you have said that your accuracy is about 98%. So I wanted to ask
Sorry,
you,
sir.
what was in the data set? Like, have you, do you have the mask which is transparent and all? Mask were also
Sorry.
inside? Like, as in your data set, do you have transparent mask also there in the data set or not?
Sorry, sir, I can't hear it.
No, I'm asking you. In your
Your
data
voice
set,
is low, sir. We
transparent
cannot.
mask also was considered or not? Because you know that is the trends right now. So different masks are there.
Sorry, sir, I can't get your voice. So kindly be low.
Transparent mask was considered in your data sets or not? Because that is the trends right now. Different masks are there.
Yes, sir. We
Transparent
have
mask.
used lots of data sets, sir. That's why we have collected a big data. Initially, we have started with a small data set, which was collected
No, I'm
from a
talking about
local
transparent
author.
mask. Transparent.
Yes, sir, it is included in our data set, and we have also it also predicted several, and we have practically experienced those wearing and those predicting those images.
Okay. Fine. And what is the time delay and in real time? How much time is taking? Have you calculated that?
We have not calculated the time, but it is quite faster than those we are.
Thank you.
It didn't take any.
Thank you, sir. Thanks so much.
So, sir, shall we, sir, complete here, sir? Sunil sir, sir, shall we complete this paper ID, sir? This presentation. Can we move for the next paper because we have less time, sir?
Yeah. Let us go to the next paper.
Okay. Please, Karthik and other people, can you please shut your camera and we will move to the another persons. So the paper ID 30, multimodal approach to personalized stress elevation. The people who is Miss Janvi here is. Am I
Yes,
talking
yes.
to? Please open your camera and please start the presentation.
Yes.
Paper ID
30. So, good morning, everyone. We'll share the screen now. So, good morning, everyone. My name is Prajakta Dange, and today I, along with my teammates Janvi Patil and Arpita Patil, are going to present an idea titled Multimodal Approach to Personalized Stress Alleviation, Integrating EEG Guided Music Recommendation stress for enhanced therapeutic outcomes under the guidance of Dr. Nihar Ranjan sir. To begin with this presentation, first of all, we will have an overview of this topic. Nowadays, stress and anxiety, these are the major problems every individual, be a teenager or be it a adults. Everyone is facing this problem and they may or may not be aware of this issue. Today in this today in this presentation, we are going to talk about the methodology that we are going to follow and the detailed discussion over the proposed system architecture for stress detection and music therapy or music recommendation system. Our approach involves analyzing EEG, that is electroencephalograph signals for stress level detection, and based on individual stress levels, the application will recommend particular music to the individuals to alleviate the stress. Now let's understand what is stress. Stress is a natural response given by any individual when they encounter any difficult situation or a situation they are unable to cope up with. Certain degree of stress is essential for the productivity and performance, but prolonged and chronic stress can have a can cause serious health issues and in some cases may have tragic outcomes. To highlight this issue more precisely, now I'll discuss one case study that emphasizes how stress can have major effects on our life. So there was this student, a bright student named Wahid. He was one of the toppers of the university. He had good grades and had a bright future. However, he was struggling with pressure of social and academic expectations. As the pressure kept building on, he started losing his grades. His family noticed the change in his behavior but called it's a normal peer pressure every university student goes through. Eventually, since his grades started to sleeping, he started to feel like a failure and started to have a suicidal thoughts. Initially, he started to avoid these thoughts, but the pain he was having, uh, it was unbearable for him. So one day when he was alone in the room, he took the sleeping pills. The next day, he woke up in the hospital
Please
bed.
make it fast, please.
Okay. In the hospital bed, but he was in a critical situation. After this incident, his friend and family realized that what Wahid was struggling and had no one to share this pain. Wahid's recovery was too long and difficult, but with proper consultation and the therapy, he was able to overcome his stress and depression. So from this case study, we can understand how important it is to detect stress in the early stages and how stress management practices would have played an important role in alleviating this stress. Now, to address this issue in everyday life, we are proposing a solution where we will be detecting stress levels using EEG signals and will categorize them into three categories: stress, not stressed, and intermediate. Further, in order to reduce the stress levels, We will be implementing a music recommender which will recommend suitable songs to alleviate the stress. Now, I'll request Janvi to proceed with the our system architecture and methodology.
Hello, am I audible? Yeah, so coming to the proposed system architecture. So the first step in this will be collection of EEG data. So we will be using a publicly available data set for the collection of raw EEG signals. And this data set consists of 1,000 trials, each trial having a 4-second EEG signal duration. And this data set consists of different emotional states such as happiness, sadness, angry, and fear. So next, in the data pre-processing, we will pre-process the data to remove the noisy data. And also we will employ an outlier detection technique to remove the outliers from the data set. Next, coming to the feature extraction, we will extract the different frequency bands from the EEG signals. So some of the frequency bands are alpha, theta, beta, and gamma. So these frequency domain features will be calculated from the power spectrum of the EEG signals. And this power spectrum will, it shows the distribution of power across different frequency bands. And also, we will be utilizing a theta beta ratio for our classifying the stress. So for the reason why we'll be utilizing this theta beta ratio, because it serves as a robust feature for stress classification. And basically the alpha waves, they are associated when a person is the theta and the alpha waves, they are associated when a person is is drowsy or is in a meditative state. So they are present when a person is daydreaming or the person is unconscious. And the beta waves are dominant in the human brain when the person is wide awake or when the person is in alert state. And also it indicates critical thinking or performing some increased mental activity. So these excessive beta waves represent stress and restlessness. So it is one of the crucial factor for indicating the stress. And for that reason, that theta beta ratio, it consistently decreases when transitioning from a relaxed state to a stress state. So once we calculate this theta beta ratio, the output will be fed to a clustering model. So we are going to utilize a model which contains k-means clustering as well as SVM classification. The benefits of using this clustering is its ability to identify similar attributes within the EEG dataset and without the need for prior knowledge of stress levels. So this will enhance the effectiveness of our stress classification. Now, after the stress is classified, it will be classified into 3 levels, that is low stress, medium, and high stress. And now the output from this classifier will be fed to the music recommendation system, which will
please make it fast very quickly. You have to make it.
Yes, sure. So this music recommendation system will recommend the songs depending on the individual stress level. Now coming to the survey analysis and discussion. So we have done a comprehensive review of different research papers.
Can you make the conclude it very fast, please?
Yeah. So these are the different accuracies which we studied, and among this, the SVM has shown a better accuracy. So we will be using SVM with a polynomial kernel for our stress classification. And also the music recommendation system will be integrated with the Spotify web API, which will suggest different songs based on the user stress level, as I said before. So now I will like to call Arpita to conclude this topic.
Hello, sir. Am I audible?
Yes.
So, sir,
please go on.
So, sir, based on the study,
So, sir, based on the study and the researches we have done on the EEG-based stress elevation, we have concluded some facts that early stress detection and the elevation is the vital in today's world. So, for the stress elevation, the integrated approach of using the schemes clustering along with the SAM classifier is the better performance. And since the music has profound effect on the both the emotions and the body music, so the music therapy will help the individuals to reduce the stress. So in future scope, this EEG guided music recommendation application can be used in the medical fields and by therapists and the physiologists in order to reduce the stress for the individuals. And so Janvi, can you please change the PPT on the references slide?
Please conclude it fast. Please fast. Make it fast. Make it fast, please.
So, sir, these are the reference research papers and the researches we have studied while doing the survey of our topic. So, with this, we have come to the end of this presentation. Thank you, sir, for having us here and giving us an opportunity to present this in the conferences. Thank you.
Sir, any questions, sir? Sunil, sir, please. Sir, so, sir, shall we, sir, move on, sir? Sunil, sir. So, shall we move, sir?
Oh, sorry. Yeah. So, why are we calling it as a multimodal approach?
So since we are hello.
Yeah, go ahead, Prajakta.
Yes, sir. So since we are using we are integrating here two models. First model will be the stress detection model, where we will be detecting the stress. This will be the first model that we are using. And based on the outcomes of this model, we are going to fetch the outcome of this model to the another, that is stress music recommendation for music therapy. So that's why we called it multimodal approach.
I'm doubtful about this because, see, if you are processing two different activities and then you are actually recommending something, that is because your input is only like identifying the stress level, right? And output is recommending a music. That is what is you are doing.
Yes, sir.
Okay, so it cannot be called as a multimodal approach. Okay, and are you using any EEG signals while learning your model?
Yes, sir. We're using raw EEG signals and we will be analyzing them. We have already analyzed them. So based on the raw EEG signals, as I said before, we will pre-process them. We will extract the necessary features which we will require, and then we will classify the stress.
What is the, I mean, how are you giving the weights to the EEG signal as well as for the score?
So weights as in what exactly?
As in like how you are, I mean, balancing that, how are you going to identify the stress level? Are you asking some questions or what?
So the EEG signals, first we will have to extract them using FFT, that is fast Fourier transform algorithm. And so basically there are different frequency bands in the EEG signal, that is alpha, beta, theta and gamma. And among that, the feature which we will be using is the theta beta ratio. So as I said before, we will calculate the theta beta ratio because it decreases while transitioning from a relaxed state to a stressful state. So this is the this is the most crucial feature which we will be using. And apart from that, yeah.
How did you evaluate the system, proposed system?
Sir, evaluate as in like
evaluation of your proposed system. How do you rate yourself? Like it is a good, bad, whatever.
Sir, it is good because it is helpful.
Good, right? So you have to conclude as a good, right? So you should have some analysis, some sort of evaluation method is required.
Yeah, so basically this is a survey paper. So we have not we have proposed the system architecture, and in the upcoming semester we are going to implement it.
Okay, fine.
Yeah. Yes.
I'm done.
So okay, sir, shall we complete the service? We need to move on, sir.
Yeah.
Okay, na sir. We
Yes.
Okay. Please, Zanvi and Pradakta and other, please unmute. And the other paper ID 86, identification and categorization of brain tumors using HOG Freezer and descriptor. Please, who will be the? Please come here and please unmute and your camera, please on your camera, please, and start your presentation and make it quick, please, quick as soon as possible. Okay. Hello, am I audible? Hello.
You are audible. You are very much audible.
Okay. No, sir. I'm asking to other people.
Yeah, participants.
Hello, Pradakta. Hello.
Can you call upon the names of participants? Who are the authors? So paper ID 56 is not available, I think.
Sir, I think he is not available, sir. Can we move to paper ID 144?
Yes, sir.
Okay. Please start 144 paper. Please start your all people of your paper ID 144. Please start your presentation. Off your on your camera and unmute yourself. Please start.
So is it visible? Hello?
Yes, it is visible.
Okay. Good morning. My name is Pawan Sai Reddy. These are my batchmates Kirti K and Ravisha JH under guidance of Akshata S. Bayer, who's an assistant professor in Ramaya Institute of Technology, Bengaluru. The topic for today will be sentiment analysis on Karnataka election 2023 Twitter dataset using machine learning. So in context of social media platforms like Twitter, where users can share their thoughts and opinions and contribute their opinions online, and users can access this information, sentiment analysis plays a crucial role. So the analysis involves classifying sentiments into positive, neutral, or negative based on user-generated content. Our study focuses on the Karnataka 2023 elections, where we collected the Twitter data using the Twitter API. We created a data set. So we collected and pre-processed the data using the Twitter API, and we applied the Navy Bayes classifier machine learning algorithm to classify it into the desired sentiment attitudes. And we obtained an accuracy of 82.05%, which was better than previous studies. So Twitter is an online social networking platform where users can create posts, updates, and they're restricted to status updates of 140 characters maximum. Sentiment analysis, it is a method of recognizing and categorizing polarity scores. Sentiment analysis, it's a method of recognizing and categorizing polarity scores. So text sentiment analysis, we use it to extract the sentiments, opinions, evaluations from the user's site on comments, and in our case, the Karnataka 2023 elections on a social networking platform, which is Twitter. The main goal of our project was to extract an arbitrary amount of data from social network Twitter and build a machine learning model and feed this data into it and classify the sentiments as positive, negative, or neutral, and evaluate the performance and outcomes based on accuracy metrics like F1 score, accuracy, precision, recall, sensitivity, etc. So this is our system architecture. First, we collected the data from the Twitter API. We collected around 10,000 tweets with 4 features created at the text, the user ID, and the username. We perform data extraction to make the data larger and for better results. We pre-process the data to reduce noise and make it more relevant for application of our algorithm. So we did this through various text processing steps, like we convert from uppercase to lowercase, which removes the unevenness of the cases, and then we remove the stop words like and, the, is. Then we lemmatization, we reduce the words to the most basic form so that there is no variations, and it simplifies the analysis. And tokenization, the tweets are divided into individual words. And next is feature extraction. We extract the features to only pick the relevant features which are needed for our model, which simplifies our task. Sentiment identification, we only calculate the polarity scores, and we use this to classify them into positive, negative, or neutral. Subjectivity identification is important because we'll separate the text based on whether the text had an opinion or which had a sentiment in it, or whether the text just had a fact which did not have a sentiment. And then this is later fed into the machine learning model. Like using machine learning algorithm, we use the Naive Bayes classification classifier algorithm. It is a straightforward classifier algorithm, a probabilistic algorithm, and it calculates the likelihood of a hypothesis given a prior information. So it calculates the likelihood that an hypothesis, likelihood of an hypothesis given an event B. So we divided the data set into a training and testing set, 75% training.
Make it fast and move to the conclusion. Please.
Okay, sir.
Please.
So these are the results we obtained. So we obtain an accuracy of 82.0%, precision 0.76, specificity 0.77, F1 score 1.42, sensitivity 0.82. And we compared two major parties, BJP and Congress. In this image, at x-axis, we have the date and time. And on the y-axis, we have the polarity scores. So we compared the polarity of both of them. So, and this, we compare our proposed model to the previous studies, the accuracies. Ours is 82%, while the prior studies are 66.24%, 70.58%, and 72%. So we can conclude that the Naive Bayes classifier, along with the TF-IDF vectorization, it's an effective text classification task. And we measure the model through metrics like accuracy, precision, F1 score, specificity, sensitivity, and we obtain an accuracy of 82.05%. And the choice of the algorithm purely depends on the complexity of the data set and the desired level of accuracy. And the Naive Bayes classifier serves good for small and simple data sets. However, there are a few shortcomings to our project as well. That is, we only evaluated it using one algorithm, and we evaluated on a single data set. These are the references we use. Thank you.
Sir, Sunil sir, sir, any questions, sir?
Okay. What data set you use for this?
So Karnataka election 2023.
So is
Our
it
own data set. Our
we
own
created
data set.
it. Yes.
No, I am getting two different answers. You are saying.
So we created a data set, sir. We created a data set using, we extracted from Twitter using the Twitter API, hashtag Karnataka election 2023.
Okay. And how many records were there?
10,000.
10,000 tweets.
Okay. And okay. And this particular method is basically evaluated or compared with what? I mean, how did you arrive at 82%? What is the accuracy formula for it?
So we just
Sir,
take.
Did you do it
Sir,
manually?
so no, sir, like the number of correct predictions by total number of predictions.
Achha. Okay. And yeah, so have you labeled this Twitter tweets with something?
So we labeled it with, so in the sense like positive, negative, neutral.
Only
We
three.
labeled it into those three, sir.
Okay. Okay, why only TF-IDF? Why not some other similarity?
So
sir, it is the best for test classification. For that purpose, we use the TF-ID
But justify your
factorization.
answer. Justify your answer. Why it is best? That is the question.
Because it is easy to implement in our model.
Okay. Now I'm expecting a technical answer from you.
Sir, shall we move for sir next presentation, sir?
Okay. Okay,
Okay, sir. It is okay, na, sir?
Thank you. Yes, done.
Okay, thank you, sir.
Thank you, Pawan and team.
Sir,
Okay, thank you, sir.
All the
Paper
best.
ID, the next paper ID, identification of categorization of brain tumors using SOG feature descriptor. Who is here?
Yes, sir.
Okay, okay.
Shubham
Please,
Gavkare, sir.
please unmute yourself and other of you group, and please
Hello.
on the camera. Okay, other all of you please
Yes,
on
sir.
the camera, please.
Sir, can I share my screen?
Yes, 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 yes.
Thank you, sir. Sir, here it is coming that you cannot start the screen share while the other participant is sharing.
Okay, okay. The another one, Pawan, please off your presentation.
So yes, so
Okay, okay, okay. Yes, start, sir. Another.
Yes, sir. Yes, yes.
Shubham Gavkar, please start.
Yes, sir. Sir, it is my screen notable. Yes, sir. Okay, sure. First of all, good morning to the all panel. My name is Shubham Gavkare and I am the lead author of this paper. Our paper name is Identification and Categorization of Brain Tumors using the Hawk feature descriptor. Coming to our abstract part, what is brain tumor? Brain tumor are the abnormal cell growth in the brain that can be thread based on the stages of tumor. And we have used a Hawk feature descriptor for the image processing.
Hello, Shubham. Please make it in. You have only 7 to 8 minutes. Am I clear to you? You have only 7 to 8 minutes. Please
Okay,
make
sir.
it in
Okay, sir.
7 minutes.
Okay, sir. Okay, sir. Okay, sir. Okay, sir. And we have used the Hawk feature descriptor for the image processing. What is Hawk feature descriptor? It is a medical imaging data which is used in computer vision to extract the features of the images. In our proposed system, we have used the Hawk for the increasing the accuracy, sensitivity, and specificity on the testing data set. Introduction. Brain tumors are a serious health concern which has a high mortality rate in human. By identifying and categorizing this tumor is a challenging due to complex nature and the current diagnostic method. This research does predictive
Can you
analysis.
just skip this introductory parts and directly come to your approach? What exactly you did in your approach?
Okay, sir. Okay.
And
Okay.
what your achievements? That's it. Okay.
Okay, sir. Okay. So this is our methodology part. Our proposed system. Firstly, we have taken 4 data set which contains MRI images. In the second step, we have done a pre-processing by resizing, grayscaling, and the medial filtering. At the third step, Hawk feature descriptor take, which is used for feature extraction. At the next step, we have used a PC algorithm, which is a dimension reduction algorithm for feature reduction. At the fifth step, we have used a k-folding cross-validation technique, which is used to create a data set into k subsets. And at the last, we have used classifiers like KNN, logistic regression, XGBoost, and SVM algorithm for the training and testing the model to classify the image into the types of the brain tumor. This is our experimental analysis. That first is data collection, then we data pre-process, then they extract the feature, and the machine learning model for the selection. Fifth one is model training. We have to train the model with the images and the data set, and we have to tune the hyperparameter technique like cross validation to optimize the performance model, like we have used the KNN model. Sixth one is the evaluation matrix. We have to evaluate our model in such parameter matrix such as accuracy, precision, recall, and the F1 score. Model validation. Evaluate the trained model on separate test data set to ensure the unbiased performance assessment. Eighth one is a categorization analysis. As we have proposed a system that categorize the image into the 4 types. So this is our categorization analysis, like glioma data, glioma image, meningioma, pituitary, and fourth one is a no tumor. Ninth one is visualization. We have plotted a graph for the visualization of the model performance. 10th one is a comparison with baseline, that how our system is different with the current or other paper baselines. 11th is the cross data set validation. Validate the model generalizability by testing it on the external or unseen data set. It is come under our future scope. 12th one is discussion and interpretation. Interpret the result and discuss the strength and limitation of the hog-based approach. Future direction. In future results. The results means our summarized data points of our proposed system. First one is objective. What is the objective? The primary goal of this research is to develop a computer-based system for identifying and categorizing brain tumor for MRI images. Second, HOG. Third is medical imaging data. CT means computer tomography or MRI are the imaging techniques used to provide the detailed information about the brain's internal structure. And nowadays, in traditional, if we take MRI images to the radiologist, it will done the study manually. But in our proposed system, we are trying to get it in automation. Machine learning algorithm. We are using SVM and XGBoost. These are the classifier algorithms. Classification. The system categorizes brain tumor into the different types such as the glioma, meningioma, pituitary, and may further categorize them based on their location and the size with the brain. Accuracy and validation, like previously we have done. The clinical application. What are the clinical application of this? The ultimate goal is to provide the tool that can assist medical professional in diagnosing brain tumor more accurately and quickly. The challenges. In challenges, we have to select one feature that we can access for the accuracy. The challenges in this research include the diversity of brain tumor shapes and texture, the need for the large and diverse training data set, and the integration of systems into the clinical practice. Future direction. Ongoing research may focus on the improving the accuracy, brain tumor identification, optimizing computational efficiency for real-time applications using the AI and ML. These are some classifiers with their accuracy, like XGBoost, logistic regression, SVM, KNN, and gradient descent, which gives these accuracy, F1 score, and the recall. In the discussion forum about our project, the model performance, starting with the trained tumor model using hub feature, and the overall performance of the model was evaluated for the accuracy and error analysis. Then comparison with the baseline, same as the previous. Generalizability. Cross dataset validation is crucial for accessing the real world applicability of a model on the external dataset. Clinical implication, like we have discussed.
Make it quick, yeah. Okay.
Yes, sir.
Make it quick, please.
Okay, sir. Okay, sir. Okay, sir. Limitations. Like what limitations we have faced, like overfitting resources about the dataset. At the conclusion part, a brain tumor can be found using a variety of techniques such as MRI, CT, but it is a manual analysis and it is difficult and time consuming. On such a technique, HOG is introduced, which has a 92 up to 92.02 accuracy rating and has produced a promising result. Here is the explanation of our research. First is effective brain tumor identification. We are effectively doing the identification and then categorize. To categorization of the tumor. Like that, previously we have it is a critical step in providing medical professionals with information needed for treatment planning and prognosis. For the third one is a quantifiable matrix. This research provides quantifiable matrix including accuracy, precision, and the F1. Fourth one is visualization. Like we have to plot the graphs of our system performance and like that. Fifth one is comparative analysis. Like we have to compare our system with the another. Generalizability and clinical significance. The research highlighted the clinical significance of accurate brain tumor identification, emphasizing how it can be lead early detection. Like if you early detect, then we can give it we can treat the disease earlier. Then future research direction. The study provided insight into the potential future research direction. It may have identified areas of improvement in terms of accuracy. We can increase the accuracy and the efficiency in our future research. Future area of research, like improved feature extraction technique. We can improve the hog technique in the future.
Okay,
Integration
Shubham,
of multiple.
I will stop you here now.
Okay, sir.
Just answer my few questions. Like, what data set you use for
Sir,
doing
we have
this?
integrating three data set like Sartaj, Fixture, and the BR35H, which contains the images which are we are going in categorizing. Like like Sartaj contains 4 types of images which we require.
Okay, hog feature extraction is actually is the main point you highlighted here,
Yes, sir.
histogram-oriented gradients, right? So, can you explain technically how exactly it is improvising the results or
Yes, sir.
contributing to the results?
Yes. Sir, hog is basically used in machine learning algorithm to extract the feature, and it is a most optimized algorithm which is used to detect the object and based on the location. So if we use a hog rather than the traditional algorithm like KNN and other stuff, that we can increase the accuracy little bit more, but we can efficiently detect
Are there
anti-categories.
any there is no any other researcher who is using this hog?
Sir, we have studied some base papers. If they are using the hog, then they are limited. Like they are using for only the detection. But we are using the hog like detection and for the categorization. So the limitation of our project is increasing. This is the main.
Okay, thank you.
Okay, sir. Can I stop my share?
Yes.
Okay, sir. Thank you.
Okay, sir. Thank you, sir. Sunil, sir, for your patient time, sir, for and be very kind of you. Sir, one more thing, sir. Sir, you have got, na, sir, evaluation sheet, na, sir, or short copy of evaluation sheet, na?
Yeah, I received.
Oh, yes, sir. Yes, sir. So, sir, kindly please, sir, share to the Bipin Mandi, sir. You have you have got, na, sir, email ID, na?
Yeah, I will share it immediately.
Yes, sir. Yes. Okay. Thank you, sir. Sir, any doubt, sir? Sir.
So thanks for joining, sir.
Yeah. Okay.
And actually, we want you to be here, but I think so because of some logistic concern, we were not able to keep the conversation.
Yeah.
Thanks for joining, sir. Thanks a lot, sir.
Thank you,
sir.
Thank you.
Okay, sir. Thank you.
Can I leave now?
Yes, sir. Yes. And